When we think of the Himalayas, we usually picture these breathtaking, pristine peaks, right? But hidden within that beauty is a pretty shocking paradox of staggering ecological damage and, honestly, some incredible scientific resilience. Welcome to this explainer, where we're digging into the haunting legacy of Himalayan mining. We're going to look at the hard data behind a region pushed to the absolute brink and see exactly how human intervention is pulling it back from the edge. To do that, we're taking a pretty structured journey today. We'll start by looking at the literal ghosts of mining, followed by the toxic runoff poisoning the Bandal River, and then we'll actually measure that toxic toll. After that, we're going to explore the amazing science of eco-restoration and wrap up with the return of the forest. So let's jump right into Section 1, the ghosts of mining and the human cost of the limestone boom. Okay, before we even get into the plants and the water chemistry, we absolutely have to talk about the people. Because the Lambi Dehar Mines in Mussoorie, they weren't just some small off-the-grid excavation site. We're talking about a place that once supported a bustling township of around 50,000 people. Think about that, an entire small city completely dedicated to rigorous limestone extraction. But the whole place was ultimately abandoned. The workers actually started succumbing to fatal diseases because of the incredibly hazardous, unregulated extraction processes they were using back then. The human cost was just immense, and it turned a booming, active town into a literal ghost town basically overnight. What's kind of fascinating about the cultural aftermath here is that today this site is completely steeped in local paranormal lore. It's actually known as one of India's most haunted places. But, while that's a super intriguing historical footnote, the true horror we need to investigate isn't supernatural at all. The real ghost haunting this region is the profound, lasting environmental degradation left behind when the people fled, and all those machines just fell silent. Which brings us to Section 2, poisoning the Bandal River, the toxic bleed of abandoned sites. The geographical stakes we're dealing with here are massive. Look at this 10-kilometer stretch of the Bandal River at Maldyota. This isn't just some random, isolated stream. It's an absolutely crucial drinking water source for the city of Dehradun. Millions of liters of the city's daily water come directly from right here. Yet this vital lifeline flows right past the officially abandoned PPCl phosphorite mines. And here's the kicker. Even though the Apex Court ordered closures decades ago, the underground nature of these mines means they are still bleeding toxic effluents straight into the watershed. And the visual evidence of this is just undeniable. When researchers contrast the upstream control site, which is nestled up in this dense forest, with the site where the mining effluent actually discharges, it is literally night and day. Upstream, the water is crystal clear, it's totally natural. But the second you reach that discharge site just a bit further down, the water turns this muddy black color. It's incredibly turbid, carrying this thick layer of suspended junk that physically blocks out the light and completely wrecks the aquatic environment. So let's move on to Section 3, measuring the toxic toll. We're looking at the vital signs of a choking river. To really understand the damage lurking beneath that muddy black water, we've got to look at the chemistry of the poison. The core issue here is something called acid mine drainage, or AMD, and it's a pretty devastating chemical process. Basically, when water and air mix with sulfide minerals in those exposed mining rocks, it triggers an oxidation process that drastically drops the pH. It's essentially creating sulfuric acid right there in the open. This acid then leaches heavy metals and highly toxic elements out of the rock, washing them straight into the river and completely scrambling the water's natural chemistry. And when you look at the hard numbers, they show a river that is quite literally choking. The healthy upstream levels get completely corrupted the exact moment that mine water hits. Just look at the total dissolved solids. That's all the inorganic and organic minerals floating around in the water. Upstream, they're at a baseline of around 300 milligrams per liter. But at the effluent site, they skyrocket to an astonishing 725 milligrams per liter. That massive spike, along with the huge jump in electrical conductivity, tells us exactly how heavily loaded this water is with foreign, toxic minerals. It's a massive shock to the entire system. But maybe the most crucial metric here is the dissolved oxygen, which is effectively the river's ability to breathe. Upstream, it's sitting at a really healthy 8.8 milligrams per liter. But down at the polluted site, it absolutely plummets to 4.9. Now, why does that specific number matter to you and me? Well, a minimum of 5 milligrams per liter is what's required just to support standard fish life. So this mining runoff creates a condition that essentially suffocates the entire aquatic ecosystem. It's starving the river of oxygen. But thankfully, our story doesn't end in the dark. Let's look at Section 4, the science of eco-restoration, and how we're accelerating natural recovery. So here is our chronological blueprint for healing. Back in 1983, recognizing just how absolute the devastation was, the Apex Court stepped in and ordered the closure of specific mining operations in the Dune Valley and Mussoorie Hills. But, just walking away and leaving it alone wasn't going to be enough. Natural recovery would take centuries. So between 1988 and 1999, they initiated active ecological restoration at the Sahasradhara and Chunakala limestone mines. Fast forward 22 years later, and scientists went back to rigorously assess how well the plant life and the overall ecosystem had actually recovered. And this purposeful acceleration of nature definitely didn't happen by accident. It involves some very strict, scientifically proven steps. First off, they had to control all that toxic drainage and stop the erosion of these massive, bare, rocky dumps. Then they brought in this incredible technique called hydroseeding. This is where they literally spray a wet slurry of seeds, soil, and mulch directly onto the barren rock just to force germination. Finally, they brought in leguminous pioneer species. These specific plants act like little biological engines. They fix nitrogen right into the barren soil, prepping the ground so that more complex plant life can eventually take hold and survive. Which brings us to our final part, Section 5, the return of the forest. Here's the data proving nature's incredible resilience. So, did these targeted scientific interventions actually work? Well, the data here is truly inspiring. Over those 2 decades, aggressive pioneer species literally dragged this ecosystem back from the brink of death. You had plants like the agave cisalana shrub becoming incredibly dominant, just aggressively taking over the landscape and gripping the soil together. Then trees like the jacaranda and the Grevillea robusta started to successfully invade these previous dead zones. By stabilizing the ground, these aggressive plants essentially paved the way for diverse food webs to develop above and below the surface. They became the architects of a totally brand new ecosystem. Honestly, the success of this entire massive endeavor boils down to one absolutely staggering number: 57.15%. After 20 decades of active restoration, scientists compared that once barren Chunakala mining site to the completely untouched natural forests right next door. And they found a massive 57% species similarity index for shrubs and trees. Let that sink in. More than half of the complex flora you'd find in a virgin forest had successfully migrated and rooted in a site that, just 1 generation ago, was nothing but toxic, compacted, dead rock. That is just incredible. As we wrap up this explainer today, we've got to look at the bigger picture. We've seen the haunting legacy of a ghost town of 50,000 workers, the choking black waters of the Bandel River, and the absolute triumph of hydroseeding and pioneer species. So we're left with a massive question. If science and nature, working together, can cure the toxic legacy of these Himalayan mines in just 20 years, how can we apply this exact same blueprint to heal the countless abandoned industrial sites and ecological scars haunting the rest of the globe? It's really a question of global survival, and it seems like the Himalayas might have just given us the answer key.